All right, guys, let's go over the answer to these practice problems, naming cis-trans isomers of alkenes. So it says, are the following molecules cis, trans, or neither, and name them. So we'll go ahead and name them first because we need to put the cis-trans isomer in the name. So let's start off by numbering our carbons. Remember, we start numbering with the side closer to the alkene. So I'm going to number 1, 2, 3, 4, 5. Okay, and with a 5 carbon chain, that means that my base name is pent. And then I'm going to have, I have an alkene here that's at carbons 2 and 3. So I'm going to have a pentene, starts at carbon 2. So we start off with the base of 2-pentene. Okay, then from here, we need to add in our substituent. So we have 1 methyl group at the 2 positions. We need to write 2-methyl. Okay, so we have this name that's almost done. We have 2-methyl, 2-pentene. Now we need to look and see what our cis-trans isomer is. So let's draw a dotted line perpendicular to our double bond. We're going to look at each side. So this first side, you'll notice has 2 methyl groups. There's the exact same thing on both sides. So this particular example does not have a cis-trans naming convention. It is neither. Okay, so that is the name. 2-methyl 2-pentene is the final name for this molecule. Okay, let's move on to the next one. Again, we need to number the longest carbon chain with the number 1 closest to the side where the alkene or alkyne is, or alkene in this case, is the lowest number. So we'll start here, 1, 2, 3, 4, 5, 6, 7. That means our base number or base of our chain name is hept. And then ene, because we have an alkene here. It starts at carbon number 3, so we have 3-heptene as our base name. Now we need to add in our substituent. We have 1 substituent off of this carbon chain. It's at the 3 position. It's a methyl. 3-methyl 3-heptene. Okay, and then lastly, we're going to look at our cis-trans isomers. So dotted line through the middle of our perpendicular to our alkene, and we're going to compare sides. So this first side here, we have a methyl group and an ethyl group. So an ethyl group is larger. So I'm going to highlight that just a little bit just to show that that one is the larger side. And then over here on this other side, we have a hydrogen versus a propyl chain. So hydrogen versus carbon. So carbon is definitely bigger. The 2 highlighted portions that I just did are on the same side. Therefore, this is a cis alkene. So the full name is cis 3-methyl 3-heptene. Great job. So let's keep going. Number our carbon chain. We're going to go backwards this time. Put number 1 where all of our substituents are and where our alkene starts. 1, 2, 3. That means we start with prop. We have ene for our alkene here. Starts at number 1. Okay, and then we have our substituents that we need to put on here. So we have 2 bromines and then 1 methyl group, all of those coming off of our main chain. So bromine comes before methyl, so I'm going to do a second line above it, I think. So we have 1 dibromo, 2 methyl. Maybe we'll just put everything, whole name below. It might fit. We'll just put a little arrow. Okay, and then we need to figure out if this is cis or trans. So if we put a double bond here, or a dotted line here. Actually, I'm going to go ahead and just redraw this molecule real quick, just because it got real messy. So this is my molecule. I'm gonna put a dotted line. I'm going to compare each side. This side has 2 of the same thing. This side has 2 of the same thing. Therefore, I don't think it showed that. There we go. 2 of the same thing. 2 of the same thing. Therefore, we do not have cis-trans isomers. So the full name for this molecule is 1,1-dibromo-2-methyl-1-propene. I don't know what just happened, but that's okay. Okay, and our last one over here, we have to number starting on the side of our alkene. So number 1, 2, 3, 4. So 4 is bute. Ene for our alkene, which starts at carbon 1. There we go. Okay, and then our substituents on here, we just have a chlorine at carbon number 1. Let's see. So 1-chloro, 1-butene. And then let's figure out if it's a cis or a trans isomer. So I'm going to do dotted line, go ahead and draw in all of the rest of my hydrogens. Let's compare each side. So on the left side, we have a hydrogen versus a carbon. So the carbon's for sure gonna win. Carbon's definitely bigger. On the left side, we have hydrogen versus chlorine. Chlorine is bigger. The chlorine and the carbon are on opposite sides of the alkene. Therefore, we have trans. I don't think I have enough room. Trans 1-chloro, 1-butene as my final answer. Okay, well, there was our practice. Great job, you guys. I hope that made some sense and that you guys are starting to get a hang of this. Definitely please practice this more and more and more. The more practice you do on this, the easier it will be. It's kind of like a formula in terms of getting these down. So I'll see you guys on that next video.